All right, we're going to go ahead and get started. It's 2 p.m. Welcome to our bonus week of Advanced Kentucky online content review sessions for AP Calculus BC. My name is Aaron Timmons. I'm the Mathematics Content Director, and I'm joined today by our co-host, Lou Akampora, who is the Senior Content Director for Science, and our presenter for today, Miss Amy Cash from Bowling Green High School. We'll get started right away. Let's just go through a couple housekeeping things first. This review session is intended for a Kentucky audience. However, I know there's lots of you from other places, students and teachers alike, so welcome. We'll do everything we can to make this an equitable opportunity to learn. However, anyone causing a disruption will be removed. Contact information for all of us is on the screen here. Feel free to reach out to us with any questions, concerns afterwards. We will be happy to get back to you. Microphones will remain off for the whole session, as will your videos. Please leave your videos off. Please use the chat feature in the bottom right-hand corner of your Zoom screen. You can chat directly with myself or Lou, or you can pose a question in the chat box. We will make sure Amy gets all of the questions and gets you the answers you need, be it a teacher question or a student question, any question at all. KYAP2020.com is where you need to go to find today's recording, as well as all other previous recordings for Calculus BC, as well as Calculus AB. So please make sure you're checking out that website. All right. So that is all I've got. So I'm going to turn things over to Amy. She can give you all a little bit of background about her calculus experience, and then she can take it away. So Amy, it's all you.
Okay. Hello, everybody. I'm going to click share my screen and just take me just a second to take over. I'm Amy Cash. I teach at Bowling Green High School and have for 20-some years. And I have been doing NIMSY reviews now for a while. I can't even remember how long I've been doing them. So I have gone all over the United States to help review students for this AP exam, but I have to say that 2020 has turned out to be quite the challenge. So I'm going to do Screencastify so you can get picture-in-picture just a second. And record. Okay, so hopefully you can see my dock camera and my hand in this picture, and you can see the document that I'm referring to right here. It's coming up. Okay, so Aaron, please let me know. So I just want to go through, first of all, just a little bit about things you should be doing before next week. It's very, 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 very important that you do try the exam day demo to practice uploading your test answers. All right. The link to everything about this exam for AP from the College Board is right here. I'm sure your teacher has sent that to you, and it is so important that you practice and you are proficient at that 5-minute upload checklist. All right. We have talked about, putting Google Drive on our phones so we can take pictures right in our Google Drive. You can literally, in your Google Drive on your phone, if I can get to mine real quick. So if I'm in the right folder, so if this is my BC folder, I can literally click Use Camera right here and take a picture. It'll go straight to my BC Google Drive. I would create an empty file folder that says, AP Calculus exam, and take my pictures straight into that. And then you'll be able to upload them on your laptop or computer. So go through that exam day checklist, confirm your email. I'm sure your teacher has told you that multiple times. But another thing is I would take either a tablet like this or loose leaf pages, and I would go ahead and write my 8-digit number at the top and my initials on multiple pages, right? So I have a tendency, if I mess up, I'll just rip off a page and go to the next one. But I don't want you worrying about your 8-digit number or your initials, so I'd have plenty of that done. I would have my reference sheet. If you have a reference sheet that you plan to use, then you need that out right now.
It should be with you every time you do a free response question, and you should be using it so that when, for instance, you need to look up mean value theorem, you know exactly where it is, okay? But more is not better when it comes to reference. Your books, if you have too much, you'll take too much time looking for things. A simple reference sheet wouldn't be a bad idea, though. Make sure your calculator's charged, your computer, your phone is charged. But basically what you need to do for this next 5 days is practice, practice, practice. There's no more to learn. There is just practice and really just smoothing out your skills as far as, you know, making sure that you show all of the hypotheses if you're using a theorem, making sure that you know how to enter problems that look different. And you know what? This year they said the test is going to feel a little difficult. And you know, but it's not going to be harder to score a 3, 4, or 5. They know it's more difficult, so that will be adjusted for. It is not a norm reference. Like, it doesn't matter if your friends score, it doesn't matter what everyone else scores. It is a test, and they're making it as fair and equitable as possible. So you could get a passing or qualifying score just like if you were taking it you know, the other day, because we should have taken it on May the 5th. All right, so where can you get free responses? From your teacher. All right, I'm sure they're posting lots of things with you. AP Central for FRQs from previous years. Those are great. I'd stay away from Calc Active because we're not going to have anything in that format. And then resources from the AP virtual exam reviews, and that is at this tiny URL. The problems that I have in today's session are from these virtual lessons. I have taken pieces from Tony Record and Brian Passwater's review that they have put up, and let me tell you, they are outstanding problems. If there's anything that I know is that they kind of have an idea that no one knows what's going to be on this test or how it's going to look, but if anybody kind of would be like able to say, I feel like it might look like this, it's those two guys, and they have all their stuff is up and all the keys are up, and I just want to give a shout out to them for A, letting me use their stuff today, and B, just being awesome reviewers. Okay, if you feel weak on a topic, then I would be looking up that video. I'm going to go through some things today. My students particularly feel like they need convergence practice. And honestly, I feel like it's going to be on there somewhere because they included it out of the last unit. Even though they omitted Unit 9, they included convergence out of Unit 10. So I believe I have a polling question about what questions are going to be, what types of convergence tests are on the AP exam this year. So if you want to put that up. And this is select all that apply. Be sure and scroll down. There's some at the bottom.
All right, we'll go ahead and end the poll here.
Thank you. Okay, now here's the thing. I have good news for those of you who said direct comparison, integral, limit comparison. Those are not on the exam. All right, this year we have the ratio test, the P-series test, alternating series, and geometric series, and that is it. So there are no comparisons, no integrals, and no limit comparisons. I'm not saying those aren't important, but those are not the ones that they chose to include in this crazy year. So that being said, in our, how do I get rid of this poll, Erin? Okay, there we go. In our handout today, I have an entire page on convergence that includes all of the tests that you need to know going into next Tuesday. Okay, so we have here, I'm going to write on this one over here. We have a function f of x is -2 over the square root of x, and says let A equal the sum, n equals 1 to infinity of a sub n, where a sub n equals f of n. And all they're doing is switching function notation into sequence notation, right? So what they mean right here is, well, a sub n is -2 over root n. That's it. It's not that big of a deal. All right. And you might want to write that -2 over n to the 1/2 power. And I'm hoping, yes.
Are you able to maximize your document camera screen instead of doing the picture-in-picture? Or make it larger?
Let's see, I can. If you feel like that would be better. I'm trying to get it to go bigger. It usually does let me go bigger, but it's not. It's not letting me get any larger. Yeah, I can go and I can maximize, and then you won't be able to see the one behind it. Is that okay?
I think that's fine. I think people should have that handout. If not, I'll put the link in there where they can go get it so you can work directly.
Okay. All right. Okay, then hold on. Let's do this. It gets a little twitchy. All right, here we go. Okay, how's that? That work?
I just see your face now.
Okay, wrong camera. Dang it. I can't see. Let's see. One more time. Is it not sharing my screen with you anymore?
Currently, you're not sharing a screen, no.
Oh, okay, gotcha. Hold on. And do one. How about?
There we go. There we go.
Okay, so now you just see my hand in the paper?
Yeah, and that works for us.
Okay, good. Okay.
Before we start, we had one person that would like you to repeat which test will be on the.
Okay.
Yeah.
Absolutely. They are the P series test, the alternating series test. All right. Geometric series, and you also have to know how to find the sum of that. And I can't spell. Okay, so, and one more, geometric, P series, alternating, and why is my brain suddenly so... Oh, ratio, sorry. Now, in the ratio test, it is just the ratio test, not interval of convergence or radius of convergence. Okay, so neither of these, just the ratio test to see if something converges or not. All right, so those are the only 4 that are on this year. Okay.
No nth term.
I'm sorry, what?
No nth term.
No nth term, right. Now, so we're looking here. Actually, you know what? I haven't really thought of nth term. Nth term isn't a convergence test. It's a test for divergence. And so I've been using that anyway, but really I haven't seen anything that where the nth term hasn't approached 0. So I don't know. I'd have to ask about that one. That one's a test for divergence, not convergence. Okay, so rewriting this function as in sequence notation, which basically means change your x to an n. Okay, I also switched the square root, the radical notation, to the power notation because I'm looking at that and I see a P series. Okay, and so I'm looking here and it wants to know, does the sum of a sub n converge or diverge? Okay, and so I'm hoping you're like, hey, that P is 1/2. All right, so on this one, P is 1/2, which is less than 1, so it diverges. the thing is, these terms are approaching 0, but they're not approaching 0 fast enough for you to add it up. It has to be greater than 1, okay? So that diverges by the P-series test. However, this second piece has you changing it, doing the same thing, but alternating, okay? And sometimes it's a good idea to write out the first few terms and just kind of see what's happening. So if I put in 1, I get -2. Plus, if I put in 2, I get -2 over the square root of 2. All right. If I get, let's see, hold on. Actually, that's going to be positive. Sorry. And then the next one is going to be -2 over the square root of 3. And then +2 over the square root of 4. So what's happening is this denominator is getting larger, all right? But the numerator is just alternating to -2. So the requirements for the alternating series test, you need to put all 3 of them. You need to be like, hey, do my terms alternate? Yes, okay? So the first thing you would say for that, you usually say, the terms are alternating. And you have to say this next part too. The magnitude or the absolute value, however you want to write it, of the terms are decreasing, this is important, decreasing towards 0. Okay, and we know that because if we're doing absolute values, they'll all be positive, but the denominator, the numerator is staying the same, but the denominator is getting larger. And if your denominator increases, your value decreases. Okay, but you have to say both of those things and then be like, well, therefore, and these 3 dots mean therefore, the series converges. Now, if you want to say by the alternating series test, be my guest, but if you have all the hypotheses in the conclusion, you don't actually have to name the title, all right? And so a lot of times people say by the alternating series test, but really you just need the hypotheses. If this is true and this is true, so 3 things, alternating, magnitude decreasing towards 0, then it converges. Okay, so someone would ask me, what if it, how do you know, what if it was decreasing, but how could it be not towards 0? Well, something could be decreasing towards another limit. Like think about like an exponential function who has a horizontal asymptote at 1. Well, that's decreasing, but it doesn't go towards 0, so it doesn't count. You'd catch that with an nth term test anyway if you were performing it. Okay, so that one converges. Okay, so this piece right here, the second one converges where the first one diverges. I think they're kind of doing this because this kind of catches something that's not on the test, which is
Absolute versus conditional convergence. And we don't have to worry about that. Those are just the pieces of it. Okay. So what I think is challenging about these questions this year is that so many times they're written in this function notation. And a lot of my students feel very uncomfortable, like, well, what do I do with this C of n thing? Okay, that's why I wanted to work these problems with you all today, because I want you to be able to see, like, well, how do I think my way through this? So in this next one, I have a sum, same kind of sum, but my new term is f prime of n over f of n. Okay, so when I'm looking at that, I have a new term. My C of n is f prime of n over f of n. Well, remember, f of n was -2 over x to the 1/2. So real quick, to take its derivative, I'm going to switch it to -2 x to the -1/2. All right? So f prime of n, which we're going to need, -1/2 times -2 is 1, x, -1/2 minus 1 is -3/2. So this C of n is x to the -3/2 over -2x to the 1/2. X to the -1/2, excuse me. All right, well, that's ugly, and I certainly don't want to work with that, so I need to clean it up. So the first thing I'm going to do is I'm going to put the x to the 1/2 on the top, next to the 3/2 on the bottom, nice positive exponents. And then I'm going to look at these and be like, okay, part of that's going to divide out. So that's going to leave 1 on the top over -2, x to the 2/2, which is x to the 1 power. So I'm looking at this sum, n equals 1 to infinity of 1 over -2x. Now, a lot of people are like, but is it kind of like a p-series? It is. This constant does not matter because we could actually put that in the front. We could rewrite this, and I put an x and it should be an n. Good thing spelling doesn't count, right? This is an n. Okay, so -1/2 sum n equals 1 to infinity of 1 over n. This guy right here should look familiar. That is the harmonic series, and the harmonic series diverges. It doesn't matter if you multiply it times -1/2. You do not have to. You don't have to pull this to the front. You just know that it can happen. This is a 1 power, so you can call this a p-test. All right. So you would be like p is equal to 1. So right. So the series diverges. Or you could actually just say simply that it's harmonic, that this one is the harmonic series and that one diverges. But really it diverges because of the p-series test. Okay, so we've seen 2 p-series where it diverged. Okay, what's required for it to converge on a p-series? It has to be greater than 1, not equal to, greater than. Okay, all right, so, I was doing this one, and look, they switched it right here to an alternating series. I'm looking at my notes. Yeah, I did it right when I did my, no, good one, Amy. I did it right when I was doing my key, and I wasn't even paying attention. So there's something not to do. Okay. It said to consider this one, and then they changed it over here. So we want to know if this alternates. So does alternating harmonic converge? Well, yes, it does. And what you could do, again, if you're trying to figure out, you're like, I'm not sure what happens, you can write down the first few terms. So the first few terms of this series would be, when I plug in 1, I get -1/2. When I plug in 2, I get +1/4. When I plug in 3, it's -1/6 plus 1/8 forever. Okay? So, are the terms alternating? Yes. Are the magnitude of the terms decreasing? Yes. Are they approaching 0? Yes. Okay? All 3 requirements are met, so this one converges. Sorry, this guy diverges. This one converges, the alternating one. All right? And you could say by the alternating series test, but you have to say all 3 of the things we said on the other ones. The terms are alternating, the magnitude of the terms are decreasing towards 0. Therefore, the series converges. All right? Sometimes it helps to write them out. Okay, so let's see if I can not mess up the next one. That would be nice. Okay, so I picked this problem because those inverses, specifically because of that inverse. All right, remember, inverse the functions, they switch your x and y. And if I were you, before the exam, I always like to go over the derivative of an inverse right before the exam because it's something we forget and it's not very hard. I don't have that on our review today, but right before the exam, I go over that. So we have a new function, g of n. G of n is the inverse of f of n. Okay, so let's go. So f of x was -2 over root x. So this is my y. So I'm going to switch x and y. So I'm going to have x equals -2 over root y. And I'm going to solve for y. So y'all switch that diagonal. Totally legal. Square both sides. Okay, so g of n is 4 over x squared. Okay, g of n, sorry. There, I did it again. Okay, so I want to know, does the sum from n equals 1 to infinity of 4 over n squared converge? Okay, now I'm hoping we've done enough of it. You're like, hey, look, p is 2. P equals 2, which is greater than 1. Therefore, it converges by the p-series test. It does not have to alternate for it to converge, all right? Okay, so that one is approaching 0 fast enough to add up. Okay, the next one I chose because, one, this looks so much different than the others, and I was like, hold on, what the heck am I going to do with that? And then, here's the thing, when you read these and you read it at the first, I completely understand. I've been teaching calculus for a long time, and I still have to read and reread and read and reread. And I'm like, what do they want me to do here? I'm like, okay. So I need to figure out what this is. Now, listen, I've already found something similar to this up here in Part B. Remember that? So I'm going to go back, and I'm going to look in my Part B, and I'm going to, and the piece of paper that's put over there, and I'm going to take my derivatives, okay, and this time I'm going to put my derivative, it's h equals, h of n is 2 to the f of n divided by f prime of n. Well, back in Part B, we used that, but we used the reciprocal of it. So I'm like, okay, let me go back and find those. So f of n over f prime of n this time is negative 2 n to the negative 1/2 over n to the negative 3/2. Remember we did that just a moment ago? Okay? And so we're looking at that and we're like, okay, let me simplify that. So this is going to be negative 2. Wait, hold on. Hold on. Okay. So negative 2 n to the 3/2 over n to the 1/2. Do I have this right? Yeah, I'm good. Okay. And so I'm looking at this and I'm like, okay, so what do I want to do? I want to see how this divides out. So this time I'm just going to have negative 2 to the nth, negative 2n. Now this is just my exponent here. Do you see that? Okay. So I'm going back up here and remember, like, this is 2 to the negative 2n. All right. So now I know that this is what I'm going to put in my sum. Now here's 2 ways to read this. When I see this, I immediately know that this is a geometric series. And here is the key. The key is the only place you see an n is in an exponent. Geometric series go with exponential functions, right? And we know exponential functions are when your variable is in your exponent. So if the only place you have a variable is in an exponent, you're like, that's geometric. I wonder if it converges, okay? So looking at this, you're like, oh, well, the base is 2, it diverges. Well, you need to slow that roll, all right? So there's a couple of ways to do this. First thing I want to do is I want to write out the first few terms. When I have a geometric series, I always want to write out my first few terms. So I'm going to put in n is 1. That's 2 to the negative 2 power. Don't leave it. 2 to the negative 2 power is 1 over 4. 1 over 2 squared. Okay? Plus. N is 2. All right? N is 2 gives me 2 to the negative 4 power. So that's 1 over 2 to the 4th. 2 to the 4th is 16. Just for kicks, we'll do one more. N is 3. 2 to the negative 8th power. 2 to the negative 6th power, excuse me. All right? So I'm looking at that, and I'm like, what is 2 to the 6th power? What's 64? And I'm hoping you can see it. You're like, hey, do you see the geometric series there? Okay, so here's the thing that you have to do. So we know what we need to do for P series. We need to name our P and say if it's greater than 1. If it's alternating series, we have our 3 things that we have to do. Well, if it's geometric, there's also things that we're required to say. The first thing we have to figure out is what is our R? Well, R is always the second term divided by the first term. Okay, so 1/16 divided by 1/4 is 1/4. You might be able to just look at it and say, oh yeah, it's 1/4. Okay, all right. The second thing we have to say is that ratio, right? Technically, the absolute value of R less than 1. Okay, and it is. Okay, that's true. So I could have just actually put less than 1 right here. So you have to name your ratio. You have to identify if its absolute value is less than 1, and that is true. And then if that works, then you're like, okay, well, I can find the sum. And the sum, this is a formula you must have to hand, is your first term, 1/4, divided by 1 minus your ratio, and your ratio is 1/4. Now, I'm going to tell you, you need to just stop right there. All right? That is not hard to do. It's not hard to put in your calculator, but we are probably going to run out of time on this test. All right? I actually was taking one of the mock exams that someone had written, and I ran out of time, and I'm a calculus teacher. On the 25-minute version. On the last question, I was, muddling through it just a little bit. It was a little weird and a little bit uncomfortable, and I ran out of time. They have said that you should run out of time. They said students that get 5s will likely run out of time. So if you feel like you're like, I didn't even finish, there's no way I'm going to pass. That is not true at all, okay? And so for that reason, one of the things that you really need to do as you work through your test is go find all the parts that you're really good at first, all right? And do those, and then go back to the parts that are going to be the parts where you're muddling. Like I said, I was muddling, okay? All right, so we have done P series, we've done alternating series. This one, the inverse one, was a P series. This one was geometric. So geometric, 3 things. Name your R, okay? Decide if that absolute value of R is less than 1. If it is, there's a sum. If it's not less than 1, it diverges, okay? So if R is less than 1, your sum is your first term over 1 minus R. It's not necessarily a 1. It's the first one. Like if this was a different number than 1, it could be something else. Okay, and stop. Okay. Evidently Siri thinks I'm talking to her. Okay. So who have we not done? Well, we haven't done the ratio test. Okay. Now, this last question here, it's different, and that's why I picked it, Straight ratio test, not too bad. So what does the ratio test tell us to do, first of all? Well, and then if they, like this question says, use the ratio test. There it is. It tells me right there. How do I know when to use the ratio test if they didn't tell me? Well, basically, it's kind of in this year's test, your last ditch effort, because if it's not geometric, it's not a P series, and it's not alternating, then you only have one choice. However, sometimes there's little clues like, remember how in the geometric one I said if there's only n's in the exponents? Well, sometimes you'll get a sum and the term will have, let me just see, what might it look like? You might have sum n equals 1 to infinity, and maybe it was 2 to the nth over n, something like that. And you're like, I don't know, it looks like a geometric and a P series at the same time. Well, then that's a ratio test problem, right? Or if it has a factorial in it, it's almost always a ratio test problem, okay? So that's what kind of happens. It doesn't fit anything else that you know, then you need to go to the ratio test. So in this weird year, all right, they're giving us problems where you're like, oh, I don't even know how to start that. So let's read this real quick together. consider the sum of k and the sum of m, where k of n is m of n times a of n. Y'all, a of n is the one we're working with this whole time. This is my a of n right here. Okay. All right. It says if the sum of k of n converges by the ratio test, where the limit equals 2/3, determine whether m of n converges or diverges. Explain your reasoning. Well, holy moly. All right. Well, the ratio test, when you do the ratio test, you have to do the limit as n approaches infinity of a sub n plus 1 over a sub n, right? Your next term over your first term, whatever, okay? And so if this is less than 1, you converge, excuse me. If it's greater than 1, you diverge. And if it's equal to 1, the ratio test is the wrong test and you need to do something else. Okay, I don't feel like that's going to happen this year. All right, so here's what they told me. So now they told me that the sum of k sub n converges and that this limit is true. So I'm going to write that out. The limit as n approaches infinity, the absolute value, k plus 1, k sub n plus 1 over k sub n. They said that equals 2/3. I'm going to have to use that somewhere. I need it, okay? Now they said k is equal to m of n times a of n. Well, all right, let's switch out these k's for these guys and see what happens. The limit as n approaches infinity, absolute value, so that's going to be m of n plus 1 over m sub n times a sub n plus 1 over a sub n. Okay. All right, so that also equals 2/3. All right, so I'm going to go back and I'm like, okay, so that's what I know. And I want to know if m of n converges on its own. Well, if m of n converges, I need the limit as n approaches infinity of m of n plus 1 over m sub n. I need to see if this answer is less than 1. Okay. So here's the thing. I need this piece, and I need to get rid of this piece. The thing that's good news here is that I know what a sub n is already. Okay. And can you all still see my screen? Because I keep getting the Screencastify yelling at me. Yeah, there it goes. Out of disk space. Okay, let's see. Plan 2, plan B. All right, there we go. Fixed. All right. So here I am and like, but the thing is, I know about a sub n. Remember the negative 1/2 that we had earlier. So a sub n plus 1 to n. Look at that. Ash, get it straight. Negative 2 n plus 1 to the negative 1/2. So here's that ratio. I'm going to put that right here and see what happens. Okay. So here's the thing. When I did this the time, I did not know where this was going. I hadn't seen the problem. I hadn't thought my way through it. This is what I did. I was like, well, they gave me this, and then they gave me k was m times a, so I changed that. Now, all right, now what do I do? And I'm like, wait a minute, I know something for a, and I'm just switching it out. Even if you don't say get all the points for this problem. If you have pieces of it, you're going to get some of the points for it. You know, who knows where they're going to put points for this question. So start something, all right? Write down what they gave you and be like, can I switch something out? Is there something that I know that I can change? And then what happened is I knew I needed just this piece, and this is going to take care of that stuff. So I'm going to clean that up a little. You might already see the negative 2's divide out, and I'm hoping that you see it's going to be a square root of n over a square root of n, and the limit of this piece right here, I'm getting a little lag on that. I'm sorry, that's why I don't like that one, is 1, okay? So basically, you have the square root of n over the square root of n plus 1. It switches because of the negative exponents. All right, and the limit on this is going to be 1. All right, so if that limit is 1, then I know that the limit as n approaches infinity
Amy, if you can hear me, you've locked up.
All right, okay. It is okay if you read the question. Yeah, I'm having some internet issues. Can you all hear me?
We can hear you.
Okay. I rarely have internet issues. Okay. So I know we had some lag on that. I'm hoping that you saw that, but here's what I want to encourage you to do. It is okay if you're like, I don't know where this is going. Start writing some things. But listen, if you don't know where it's going, go find the questions first that you do know where they're going, and you can get those. But if you have time and you're working through, it is okay. You maybe will get a point or two of partial compared to the whole thing. This one worked out. All right, that's how that happened. All right, so that is all for convergence. Okay, we have our 4 types of convergence. That is all that is on our test next week, and we're finished. Okay, so some other things that I have pulled for you to look at are on page 3, we have this tabular. All right, and I've put some of the AB stuff on there, and I've just left it on there for you to practice on your own. I'm going to put the key up, and so you all can look at this. So you see this, that is just a chain rule problem, read from a table. This one is looking like a L'Hopital right off the bat, so hopefully you know how to do that. But see part C, okay? This is a BC integration technique. So I think I have a poll question for that, I think.
You do. It's coming up right now.
I know. What are the BC integration techniques? BC only. Looks like we're about done.
All right, we will cut it off here.
Okay. All right. So y'all, integration by parts, BC only. Partial fraction decomposition, you may know that as the Heaviside method, is BC only. U sub is AB. Power rule is obviously AB. Completing the square, also AB. Improper integrals is BC only. Those 3. Okay. All the rest are also AB things. Okay. So knowing that, I put in this one. And so when I think of integration by parts, all right, I have already looked at this and said, hey, does U sub work? Because if here is the list of things that when I'm teaching integration, I'm like, here's where you start. You start and look and say, is it a known derivative? Okay, that's your first thing. And that would be like the integral of cosine. Cosine is a known derivative. Another one would be the integral of f prime of g of x times g prime of x. That is the chain rule, right? So the antiderivative of this is f of g of x. All right, these are known derivatives. That's your first job. Okay, if that doesn't work, we go to u sub. Okay, if u sub doesn't work, then we have to start being like, well, what are my options here? Okay, and the partial fraction decomposition and completing the square look similar. So when do I use one and when do I use the other? If you can factor the denominator, it's partial fractions. If you can't, then it's probably completing the square. It's an arctan or an arcsine. And then we also just have other things where, well, what if it's what I say is like top heavy? So like if you had x to the fourth minus 3x squared plus, I don't know, over x minus 5, right? And you were trying to integrate that. Well, the u sub doesn't work, but if I use synthetic division, I can clean this up and make it work. All right. So if it's top heavy, I got to divide it out. What other things am I going to do? One of the last things I want to do is partial fractions. All right. Excuse me, it's not partial fractions. Integration by parts. This one is integration by parts. But sometimes they just say, hey, look, I'm integration by parts. You have multiplication. All right. And the two functions are not related. You cannot do u sub. Right. So for instance, if this inside, let's see, if it was x g double prime of x squared dx, this is u sub because x squared, the derivative of x squared is 2x, and so you can take care of that with u substitution. Okay, this one, I don't have a u that works. Always try u first. All right, but I'm looking at this multiplication, I'm like, it looks to me like that's integration by parts. You're multiplying two different functions, okay? So it's the last thing I do. And so I have the integral from 1 to 8 of x times g double prime. I'm hoping all of you have learned the tabular method for this and that you know what is how that works. So in the tabular method, you put your u version on the left and you take its derivative, x, derivative of x is 1, derivative of 1 is 0. Okay? It has to, tabular only works if you take a derivative and it goes towards 0. Okay? On the second side, you pick your dv, is g double prime, and you do antiderivatives. The antiderivative is g prime, and derivative of that is g. All right? Then we add this diagonal, subtract this diagonal. Okay? That is tabular method for that UDV process. See, there's two. If you do it the long way, you're going to have to do the process twice. It's not really a big deal. It's not that hard. It just, this is quick and easy. Minus g of x from 1 to 8. All right. So if you've done a good number of those, all right, you can do integration by parts really fast. Okay. All right, so from here, we just have to read those numbers from the table, okay? And so I'm going to do 8 g prime of 8 minus g of 8 minus 1 g prime of 1 minus g of 1. Still not done. I cannot stop until I pull the values from my table. I'm not allowed. I cannot stop here. I had somebody do that on a mock exam yesterday. I cannot stop here because I haven't read from my table yet. So in the end, I've got 8 g prime of 8 from my table is 1 minus g of 8 from my table is 16 minus, I need a parentheses there, 1 times, and I usually don't always write that, but g prime at 1 is -4 minus, and g of 1 is 5. Now I can stop, and I should stop. Don't evaluate. This is the answer. You're finished. Okay. So I've also scored things recently where a student has everything right here, and then they make a simple computation error and they get it wrong. Just don't do the computation. It's a waste of your time, and it's a possibility you could mess it up. Okay, So that's for this one. All right, looking at those. If BC integration makes you nervous, go watch the video on BC integration techniques from the College Board. It was really good. Okay, next one. Working with a differential equation and an Euler's method problem. This is our last one down here. Okay, all right. So Euler's method is, one of those things that it's BC. I don't know why it's BC only. All right, but I'm betting that 5 out of 6 of you use a table for that. Okay, and if you do, you may not want to watch me do this. All right, I do not like the tables, and I'm a Monique Morton. Monique Morton Rice is my mentor, and she did APS. She trained me, and when she did Euler's method with me, she showed me how to do it. It's just doing tangent lines. And here's the thing: we are really good at tangent lines. Okay, and so this is the information I have. Okay, and I have h of 1 is 3. I want to estimate h of 3. All right, I want to estimate h of 3 with 2 steps of Euler's method. Okay, and so all I do is I write the first tangent line. So when I write a tangent line, I write down my point and I write down my slope. Well, my slope is my derivative. So x is 1, y is 3. So f of g of 1, reading that from my table, f of g of 1 is 1. Plus 2 times my y value is 3. So I have 7. So my slope is 7. My point is 1, 3. So my tangent line is y equals m x minus h plus k. That's my line. All right. I don't clean it up. I don't simplify it. But I use my tangent line to do a tangent line approximation. I've done that 100 times as an AB student, right? So I want to go 2 steps. So I need to do h of 2 first. So I'm going to say h at 2 is approximately 7 times 2 minus 1 plus 3. All right. So there's your delta x for those of you who do it that way. There's your delta x is 1. All right. 7 times 1 plus 3 is 10. Okay. So there's my first step. Start over. I have the point 2, 10. I have a new slope. I need f of g of 2 this time. F of g of 2 is actually 0 plus 2 times y, 2 times 10 is 20. Okay, so there's my point and my slope. I'm going to write a new tangent line. Y equals 20, x minus 2 plus 10. All right, and I'm going to use my new tangent line to estimate h of 3. There's my wiggle again. Remember, when we're estimating, we don't put equals. Okay, so I put my 3 in, 20. There's my dx. 3 minus 2 is still 1, plus 10. And I stop there because, why do computation? All right, so when I do Euler's method and I teach Euler's method, I do not use tables. I just do a tangent line, rewrite, and then start over and do another one. It's just repeated tangent lines. And because my students have already been doing that, they don't find it to be difficult. There's no table to memorize. There's no trying to understand the formulas that people use. It's just, I'm just going to repeat that process. And then we look at it visually too to see why that makes more sense than just doing a tangent line. This would be a better approximation than just plugging 3 into my first tangent line. That's the whole point of it. So if you've learned another way and you are good at it, then 100% you should do the table or whatever process that you're good at. I've had a lot of success teaching it this way, and Monique is a rock star, so much of what I do I learned from her. Okay, there's one more integration technique that I want to talk about with you, and that is improper integrals. And that shows up in the graphical stem problem on page 4. On page 4, we have to back up a little bit. On page 4, we have a graphical stem of f prime. They tell us the graph of f prime, the derivative of the continuous function f is given above. The graph f prime consists of 4 linear pieces in a quarter circle centered at 2, 2. So there's my little quarter circle right there. For x is greater than or equal to 4, f prime equals negative 2e to the 4 minus x. So this right here, this piece right here is that function right there. F of 0 is 6. Now back in part B, we had to find values for f. And so somewhere in part B, we had to figure out that f of x was f at 0 plus the integral value from 0 to x of f prime of x. Okay, somewhere in there. This f of 0 is 6. Okay, so this is 6 plus the integral from 0 to x of f prime. That's just straight FTC. All right, initial value, derivative. So I want the limit as x approaches infinity of f. So I need the limit as x approaches infinity of 6 plus the integral from 0 to x of f prime of x. There is my improper right here. Do you see that? X is going to infinity. And I'm like, well, I'm wondering, so I want the limit, and this we can use areas from our graph, all right? And I'm like, oh, as x goes to infinity, f prime is this guy right here, so I can just integrate that. Well, this does not start until x equals 4. So I have to, first of all, split this up. X approaches infinity. I've got my 6, but I have to do the integration. I have to use this area and this area from 0 to 4 because this function doesn't start until 4. So it's going to be 6. The area right here, I'm going to just say, trust me, it's 4 minus pi. This area is 2, but I'm going to subtract it because it's below. And then I'm going to do plus the integral values from 6 to x. So this is 6 to infinity of negative 2e to the 4 minus x dx. There is our improper integral that we have to do. This all came from the graph. This is the improper integral. Now it's exponential. It's a very simple antiderivative, but I wanted just to point that out for you all. Okay, so I'm not going to finish that because I do want to talk about this Taylor polynomial real quick, and we only have 2 minutes left. But doing this antiderivative and find the limit as x approaches infinity, that is the improper part. Okay, last thing, quick as I can go. We've got g, this function that is related to the f prime function up above, okay? And we want to find P2, the second degree Taylor polynomial to g centered at x equals negative 1, okay? So when I start these, and I hope that you do this as well, when I write out a Taylor polynomial, I first write the formula. So it's g centered at negative 1. So that's going to be g of negative 1 plus g prime of negative 1 times x plus 1 to the 1 power plus g double prime of negative 1 x plus 1 squared over 2 factorial, using that formula for a Taylor polynomial. Okay, so now I need to find g of negative 1. Well, I'm looking up here. That's 3 minus the integral from negative 1 to negative 1. That's going to be 0. So this is just 3 plus. All right, the rest of it, I have to find g prime. So you're taking the derivative of this. Be careful, because I had a student today forget to take the derivative of the constant. All right, so you have to take the derivative of this, and that's FTC. Don't forget the minus out in front of it. So that's going to be 2f prime, it should be negative 2f prime of 2x plus 1. All right, the negative out in front. And then you got to sub in. All right, and then you have to find the derivative of that and read it from the table. And you can. I'm just out of time. Okay, but I hope that you see they're putting this fundamental theorem and chain rule stuff all in here, reading from a graph into a Taylor polynomial. This kind of question, I feel like, is going to show up next week because there's so much in it that they can give you credit for knowing the calculus on. Okay, so I will finish that and put the key up, but we are at 2 o'clock. Well, my time it's 2 o'clock, 3 o'clock your time. And I don't think that we want to go over.
If
So
you have anything really good, you can go a couple minutes, but if not,
I can go a couple minutes. Okay, let me finish that one then.
All right.
Okay, it's a good problem. All right, so I need to find G prime. So G prime of X, the derivative of 3 is 0, so I don't need it. Then I've got my negative. The derivative of an integral, that's FTC. I'm just going to put X in for T. So I've got 2f prime of 2x plus 1. Be careful. I don't need chain rule here because the derivative of X is 1. I'm finished there. So there's my G prime of X. At X equals negative 1. Let's see. So I've got negative 2f prime of negative 2. Going up here, looking at negative 2, f prime at negative 2 looks to be a half. Okay? So 2 times 1/2 plus 1. All right, so 2 times 1/2 is 1 plus 1 is 2, so I've got negative 2 here. So up here, I'm going to put in my negative 2x plus 1 plus. All right, now I have to go again. I have to find my second derivative of G. Okay, so this negative, now listen, if you want to distribute the negative, it doesn't matter. But I got my 2. F double prime of 2x times the inside derivative, so times another 2, plus, and the derivative of 1 is 0. So this is negative 4f double prime of 2x. Okay, at x equals negative 1. I'm like, okay, so this is going to be negative 4 f double prime of negative 2. Now, real quick, let me point something out. Do not sub in a negative 1 without either this line or going over here and saying this. All right? Don't just put equals and sub something in. That is a linking error. You can't do that. All right? They don't always equal this. They equal this at negative 1. So f, the second derivative, the slope of f prime at negative 2. I'm going over here.
The slope of negative 2 is negative 1/2. All right? Do you see that? So this is f prime. The f double prime is the slope, so it's negative 1/2. So negative 4 times negative 1/2 is, again, 2. Okay? And so this is 2x plus 1 squared, but do not forget over 2 factorial, and you do not have to simplify, and I don't. All right? My next one would be cubed over 3 factorial, blah, blah, blah. Do not put an ellipsis here. And an ellipsis means ... There are no ellipses on a polynomial. They will take off, you'll lose your point if you put an ellipsis on a polynomial. And so we aren't writing general terms this year for Taylor series, so there won't be, when you're doing a Taylor, it's going to end. No plus ... Okay? Because then it's no longer a polynomial, it's an infinite series. Okay, so you have to be careful about that. Okay. Aaron, were there any questions that people put up?
No questions came through on my end.
Okay.
So I think we're okay.
Okay, so I got all the BC things done. So that's a miracle.
All right. Let me share my screen here for 1 second. All right. So again, thank you, Amy. Excellent job. I think that was a lot of material in a short time. But I think that's what people probably want here with being crunch time before the AP exams. So if you need to get in contact with myself or Lou or Amy with any questions, please feel free to reach out to us via email. Give us a follow on Facebook or Twitter. Handouts can be accessed at the bit.ly link there, as well as kyap2020.com. This recording will be posted there by the end of the day as well. Next week, there are no more review sessions. It's the actual AP exams. So Tuesday, May 12th, 2 p.m. Eastern Time. Best of luck to all of you. Amy, do you have any closing remarks before we sign off?
Just practice those FRQs, guys. You can do this. It is totally doable. So I feel like if you practice, you're going to be ready on Tuesday. So good luck.
All right. So best of luck to everyone again, and hopefully we'll be seeing everybody soon. So take care, and we will see you all later.